Hi, Andrew. I just wanted to explain number 4E from the practice test. So what it means for the boat to moor at the end of the pier is for the boat to attach to the end of the pier, or like with a rope, or to throw an anchor. And it says the water needs to be at least 3 meters deep for the boat to be able to moor at the pier, or to attach to the pier. So basically what you want to figure out is in what range, what time frame after 12 noon will the water be at least 3 meters deep. So that means after 12 hours have passed, right? Because t equals to 0 represents 12 a.m. midnight. So we want, if we're thinking about on our graph, we want to know after 12 hours, so after 12 p.m., between what times will the water be at least 3 meters. So we can find the points of intersection. If I think about the horizontal line at y equals to 3, here I'll use a different color on here. So at y equals to 3, okay, there's going to be 2 points of intersection after t equals to 12 that are within the 24-hour period. So I want to find this point of intersection, and then my graph is cut off. So on my calculator, in y sub 1, I graphed one of the equations. I just used the sine equation. And then in y sub 2, I did y sub 2 equals to 3, because I want to find the point of intersection between that horizontal line at y equals to 3 and my sinusoidal function. For the window, because we want to know between what times after noon, I did my horizontal axis. So in the window, it would be my x-min. I did my x-min as 12, and my x-max is 24, right? Because that would be between noon and midnight. And then for my y-axis, my vertical axis, I did from 0 to 6. And I'm able to see both points of intersection. And I found both points of intersection, which end up being 12.79. I'm not sure why I only rounded to 2 decimals here. But the first point of intersection is 12.79, and the second point of intersection is 20.51. And that's in hours. And we want to determine what the actual time is. So between those 2 times is whenever the water will be at least 3 meters deep. So converting, 12.79, that's still in the noon hour, and I want to figure out how many minutes into the noon hour. So I take that 0.79 and I treat it like it's a percentage of an hour. I want to figure out what is 79% of an hour in minutes. So I do 0.79 times 60, and I think I end up with 47.4. So I just rounded that up to 48 minutes. So the first time would be 12:48 p.m. approximately, like just before that the water would be 3 meters deep. And then 20.51 hours, 20 hours after midnight would be 8 p.m. And then I want to figure out what 51% of an hour is in minutes. So I do 0.51 times 60, and I get 30.6, which I rounded up to 31 minutes. So I know in between 12:48 p.m. and 8:31 p.m. that the water will be at least 3 meters deep, and therefore